I am Venkatesh from Bannar Yamun Institute of Technology, and for the hackathon, we had chosen a problem statement called Micro-doppler based target classification. Let me explain what it is and how it works. So we have to separate birds and drones. Since the drones are getting cheaper and cheaper, the misuse of them has been increasing. So there has to be a way in which drones and birds can be separated. So let me explain how we separate based on micro-dopplers. So, drones and birds make different sounds and produce different spectrogram and signatures based on the sounds. Um, the Doppler effect produced by a drone will be more denser since it is moving at a higher speed. The spectrogram will be having a wider depth. And for the bird, it is moving at a lower speed. Let's say 2 flaps per second. The depth will be lesser and it will be more less periodic. So these are the differences in which we are going to train a AI model. We will be giving the signatures as input images, and we will train a AI model to differentiate these input images and produce a class at the end, whether a particular image is bird or drone based on that. So our idea is to make a basic take inter UI coupled with support vector machine, the ML model that we are going to use to differentiate birds and drones upon micro-doppler signature as input. If we give input is the signatures, we will differentiate birds and drones. For that, we are using 10 gigahertz signatures, 1600 images of bionic bird and quadcopter, and pass that into STFT. Let me explain what it is further. To get those these spectrograms, These spectrograms are further classified into 128 into 128 images with the batch size of 64. We are getting 15 epochs if we keep the batch size of 64, and we will train 15 epochs one by one so that we get higher accuracy. So we are using a linear SVC classifier, and the reason is from the research paper we get to know for the particular task, linear SVC classifier provides a higher accuracy rather than CNN and other models. So we are splitting the data 80-20, and with that we got an accuracy of 96%. So what it means is when we give this two as an input, our model can 96% times can predict drones as drones and birds as birds. So developer workflow. Once the user will input this as a raw image, we will convert the image into spectrograms, and we will convert into grayscale for model purposes, and we will convert the grayscale image into CSVs, the 1D vectors. The 1D vectors will be passed into a ML model called SVM classifier. Based on the values, it will classify whether a particular image is bird or drone, and in the take inter UI it will show that a particular image is bird or drone based on that, and we test the data and we'll provide a F1 score based on the how model is accurate on predicting between drones and birds. So for the tech stack we are using Python, and for the spectrogram generation you are using Fourier series STFT. It will convert this image into periodic ones. So we are using MATLAB for as environment, and these libraries are used for specific purposes from one to another. The model achieves 96% accuracy, and it differs between different tones. It achieves 90% accuracy, which is highest at the current state. So these are some risk and mitigation strategies, and the target audiences mostly defense organizations. And for the references, we have took four references, and GitHub page shows our code, and the YouTube playlist shows how we work on further.